Hello. We have talked about intellectual property, and when you have a rule or law protecting the new invention and creative work, we have to think about two things. Number one, reviewing the last class, you have to encourage the new creative thinking and ideas. However, that might suppress the spreading of the ideas to the general public. So we have to balance it, which is never an easy job. Okay, and in general, once again, uh, in this modern society, the new ideas are the most valuable one because the advancement of technology has been very slow in the past, but as everybody know, it is very fast. Everything becomes new, and after 2 3 years, the old ones are really old, and you have brand new ones, which has a great value. So, encouraging these new ideas and spreading around it around the world is really important in this new economy. Okay, we are gonna go a little bit into the detail. First, the patent. And the first topic is breadth of patent. Breadth is the noun of the broad. Okay, what does that mean? The best way to explain it is, I think, by this example. Let's think about two people, inventor, Tim and Sam. First of all, Tim spent some time and money and invented what is called dog bathing machine. So, I never raised a cat, but I guess when you have a pet, you want to bathing them, otherwise they smell really badly. But then it's not its job. So somehow Tim invented a machine. You put dog in there, and it's squeaky clean, and it's bathing everything and soap and everything, and it comes out a very clean dog. Okay, like dog laundry machine. I don't know, whatever. Dog bathing machine. DBM I would call. Okay, and get a patent. Next month, somebody named Sam, another inventor, invented a cat bathing machine and applied for the patent. If you're a government officer who's in charge of giving patent, would you give a separate patent to this cat bathing machine CBM when you know there is a DBM? Or would you say, oh, cat bathing machine, basically this is same as the dog bathing machine, and I cannot give another patent, independent patent for it. Okay, should Sam get a new patent? Here comes the terminology broad rule and narrow rule. If you think the Sam's cat bathing machine, that must be very similar to dog bathing machine. I mean, to some degree. They are not going to be exactly same. I'm talking about hypothetical inventions, but the dog bathing machine, cat bathing machine, they are not, like the cat bathing machine is not really, really, really new out of nothing. When you see the dog bathing machine, there must be something similar in it. Okay? So if you are have the faith of broad rule, which means they are similar, then they are the same thing. That is broad rule. So you would not give patent to Sam because you basically believe cat bathing machine CBM is same as DBM. On the other hand, if you are a judge who believe in narrow rule or patent officer who believe in narrow rule, you would say, come on, how can a dog be same as cat? So yeah, there are some similarities, but there are strict difference. So CBM is different from DBM, so CBM, cat baiting machine, deserves another new patent. Right. So that is broad rule and narrow rule. And from this example, you can imagine in real world, there's a lot of debate on it. Because in this world, when you invent something, that's very hard to be brand new out of thin air thing. They usually are the improvement of something. Okay? So it's always debatable whether you give patent to something that has improved from something else, something we already got the patent. So, without getting into it, what is the good side and bad side, merit and demerit of broad rule and narrow rule? First, we have two criteria. Number one, speed of invention. Which would encourage speedy invention? The broad rule or narrow rule? The answer is broad rule. In broad rule, if Tim and Sam competing, like Tim want to invent dog bathing and Sam want to invent cat bathing. If Sam wins, Sam invent cat bathing machine one day before Tim invent dog bathing machine, Sam not only gets the patent of cat bathing machine, it gets the patent of dog and every other furry animals bathing machine. Which means you can make money not only from cat bathing, but also dog bathing. So the money is much bigger and the winner gets everything. Then are you going to speed up or are you going to slow down? In this world, they are going to speed up. What about narrow rule? They are not going to speed up. Actually, they have an incentive to slow down. Think about that. You are a Sam and you have some idea about cat bathing machine. But then you have to spend enormous time and money for research and development. But then you realize your neighbor inventor team is working on dog bathing machine. And you think, instead of inventing cat bathing machine out of thin air, I'll wait until team invents dog bathing machine and I would say, oh, I just buy one of those dog bathing machine and analyze it. Then I would have a great idea how to build cat bathing machine. So my time and energy and money would be considerably reduced for the invention of cat bathing machine. So in the case of, and then why do you do that? Even though Tim invented dog bathing machine, you can get the money from cat bathing machine. So because they are differently patented. And when you can get the same money, what you want to do, you want to save the cost. How can you do that? You wait until the other guy invent the thing and look at it, get an idea, and make yours. Because they are similar thing after all. Okay? So, as long as the speed of invention is concerned, broad rule encourage it a lot. People compete each other and they try their best to invent it quicker. But narrow rule, they have incentive to slow down and like, please, team, you invent first. No, Sam, you invent first. They want to yield to each other and wait, so the invention would be slow. Of course, we like the society to improve quicker than later, so speedy invention is important. So in that sense, broad rule is the winner. So why don't we choose the broad rule all over the world? There's another criterion that is R&D cost. If once we know that in the end, dog bathing machine and cat bathing machine would be invented anyway, other than speed, what we are worrying about is how much would it cost? For invention, you have to invest your time and money, that is R&D, research and development investment. And if you look at the broad rule I already mentioned, Tim and Sam is going to independently compete each other. And Tim has this new idea. He would never tell Sam. He would guard with his life because if Sam knows that, Sam may win. So they are hiding each other's technology until they invent things because the winner takes all. You don't want to tell the information to your neighbor. Okay, so Tim invest R&D separately and Sam invest R&D separately. So maybe dog bathing machine needs $1 million, $10 million investment, and cat bathing machine needs $10 million investment. Together, $20 million investment would be needed. What about narrow rule? It's slow, but the team invest 10 million and dog bathing machine. Sam, in the best case, he wouldn't invest anything. He just look at and copy and everything. So instead of the broad rule where $20 million is needed to invent DBM and CBM, the narrow rule, maybe just 10 million, half of that amount would be enough to have two inventions. Okay, so narrow rule save a lot of investment cost. So once again, these two rules has merits and demerits each other. Similar word, but then it's not just equally similar. Like let's think about the time differences. So there are basically two inventions and ideas. One the book is calling pioneering invention. Okay. And the other is commercial applications. When we talk about invention and new ideas, you may think, oh, when I have a new great idea, I automatically make money. Sorry to tell you that, but that's not the truth. Think about the famous Albert Einstein. He has the theory of relativity. But do we use the theory of relativity in real life? No. Did Albert Einstein invent something useful out of theory of relativity? I don't think so. He got prize. So he get money by prize and lecturing to the famous at the famous universities, but out of the theory of relativity, he didn't make anything useful. Okay, so somebody like physics professor, I will say Kate. Let's look at the example. Physics professor Kate discovered water power. It's a make-up word, but like you make energy not from petroleum, not from coal, not from natural gas, but you use water to make power. Wow, that's great. So the theoretical physicist Kate, famous Dr. Kate, has discovered theory of water power. So she basically theoretically proved that water can be the source of great energy. But he does not tell you how that can be done. That's usually done by not physics or natural scientists, but engineer. So we assume that there is an engineering professor, Jane, okay, famous professor, who used this water power theory and make the water car. So instead of petroleum gasoline, you put water in your car, you can drive your car. Great, isn't it? Okay, so in this case, the physics professor did pioneering invention, which should be the first. Without pioneering invention, the second one, the water car, commercial application is not possible. So we have two inventions. Pioneering invention first, commercial application second. We need both. Just one of them is not enough. We need both to have something useful, something you can make money, like water car. Okay? Here, I'm going to give you a specific number. DNA costs for Kate and Jane are $10 for water power, $20 for water car. Commercial values of water power and water car is $0 and $50. You want to have a car, so somebody willing to pay $50 for the water car, but water power is only theory. I mean, nobody pays something to the theory. Okay? Of course, this means the water car should be invented because the value for the society of the water car is 50. The cost of it is 10 plus 20, which is only 30. So if the water power pioneering invention and water car commercial applications are both realized, the cost would be 30 together and the value would be 50. So the net increase of society's value is 20. So we want this thing to be invented. So in this case, which is better, broad rule or narrow rule? What do you mean broad? Go back here. If it's a broad rule, the water power theory was suggested first. Maybe it was patented first, then water car is invented. If it's a broad rule, the water car license belongs to the water power. So if Jane wants to make a water car, she has to get permission from Kate. Because Kate knows the theory in this case, she cannot make water car by herself. It's the engineering job. What Kate would do is, okay, you give me the royalty, then I'll give you the license, which means I'll allow you to use my water power theory to make the car. Okay? So that is the case of broad definition. So in the broad definition of this invention, the Professor Kate, who first discovered water power theory, get all the patent power. On the other hand, if it's a narrow definition, then the water power theory and water car are different things, so they would get a different patent. That is broad definition and narrow definition concerning this case. What would be the result? That depends on the transaction cost. Okay? If the transaction cost is 0, then both broad and narrow definitions are efficient. Why? They will negotiate and they will end up doing the efficient thing. Here, the efficient thing is Kate and Jane work together and ultimately make the water car. Okay? How would it be happening? If it's broadly defined, then once Kate make the water power theory, the Jane or Kate would meet each other. Okay, they find each other. And Kate say, oh, why don't you make a water car? You can make $50 money. And Jane said, okay, I can make it by investing $20. But then the law said, if I make water car, you will get all the money. And Kate said, okay. You pay me something like $20 for using my theory. So I will allow you using water power and do whatever you want to do as long as you pay me $20. As a result, Kate would earn 20 minus 10 because this costs $10. And Jane would be happy because she can make $50 out of water car once she invent it. Then it costs her $20 and she pay Jane $20, but still Kate $20, but still Jane has 50 minus Jane's cost 20 and royalty payment to Kate 20, still has $10 profit. So this Jane and Kate, by negotiation, divide the $20 profit to 10 and 10, and they will do it. They will agree upon that. What if it's a narrow definition? In this case, Kate will not invent it first because she will spend $10, but water power theory has zero value. So she knows that if I do that, I lose $10. But then Jane will come to Kate and persuade, Kate, please, I know that you can discover the water power theory. And Kate said, yeah, I can do that, but then I'll lose money. And Jane said, oh, I will fund you. I'm going to give you $20. So you spend $10 to theorize the water power theory. But then because I gave you $20, you earn $10 profit. Then, because water power and water car are different things, what will happen? Jane paid 20 to Kate, and once Kate make the water power theory, Jane spent $20 to make the water car and receive $50. So once again, Jane can earn $10. So it's the broad definition and narrow definition. It's more like in broad definition, Kate looking for Jane. In narrow definition, because Kate wouldn't do at first, Jane looking for Kate. But in the end, they will negotiate and they'll find a way to both of them to make money. And then the result would be efficient so that the water power theory would be used to make water car. So once again, everybody is happy, everything is efficient when the transaction cost is zero. Okay, I think it's going to be a little bit long lecture if I continue. So I'll stop the lecture here and continue when the transaction cost is bigger than zero in the next lecture. Thank you.